All right, so today we're going to dive into something called axiomatic causal graph dynamics. I know it sounds like a mouthful, but stick with me because it's actually a super powerful new way to make sense of our incredibly complex and, let's be honest, pretty unpredictable world. I want you to just think about this for a second. Seriously, how would you even begin to model a game where the board itself is shifting, the pieces can suddenly change, and the rulebook is being rewritten as you play? That's the huge problem we face when we try to understand so many systems in the real world. And that right there is the core challenge we're talking about, the challenge of change. We're just surrounded by systems that are always in motion. Financial markets, social trends, you name it. And they evolve in ways that can seem totally chaotic. I mean, think about a viral video that just explodes overnight, or a sudden stock market crash that seems to come out of nowhere. These things don't follow some nice, neat, predictable script. So you can see why the old ways of modeling, the ones that assume everything stays the same, they just don't cut it anymore. We need a new tool. So to really get a handle on this new tool, let's use an analogy that I think just nails it. We're going to look at the difference between a scripted play and a live improv show. The old way of looking at things is like a super detailed play script. Every single line, every action, it's all written down. It's rigid. But the new way, this causal graph dynamics, it's way more like an improv theater. The actors, the story, how they all interact, it evolves right there on the spot. It's flexible, it's dynamic, but, and this is the key, it's not total chaos. Even improv has some ground rules. Okay, so if our world is basically one big improv show, what are its unbreakable rules? To figure that out, we've got to understand the stage, the actors, and the performance itself. First up, we've got the causal graph. The easiest way to think about this is it's the stage and all the actors on it. These actors are what we call nodes in the system. And a node could be anything, really. A person in a social network, a computer on the internet, even a single idea. The graph just tells us who can interact with whom. It's the basic blueprint of the system. And then you've got the dynamics. This is the show itself. This is the action, the conversation. It's the way the whole story unfolds as the actors actually interact. So the graph gives you the structure, but the dynamics, that's the life happening within that structure. But here's the thing, right? A good improv show isn't just a free-for-all with people yelling random stuff. For the scene to work, the actors all agree to follow some basic, fundamental rules. And it's the exact same for these complex systems. Underneath all that apparent chaos, there's a set of core principles that just can't be broken. These unbreakable rules are called axioms. That's the axiomatic part of the name. And they are, as the source material puts it, a minimal set of non-negotiable axioms. They don't tell the actors what they have to say, but they set absolute limits on how they're allowed to interact. And the biggest, most important axiom of them all is this: a universal speed limit. It's kind of like in physics, where nothing can go faster than the speed of light. Well, in these systems, information can't just teleport from one place to another. It actually has to travel from node to node, and that takes time. So, for example, let's say actor A learns a juicy secret. They can't just shout it across the stage to actor Z. Nope. They have to pass it to their immediate neighbor, actor B. And then actor B has to pass it to their neighbor, and so on and so on. That information has to travel along the connections of the graph. There are no shortcuts, no instantaneous leaps. So what's the payoff here? We have this powerful new framework, this whole improv theater with unbreakable rules. What does this actually let us do? How does it help us model our crazy, dynamic world? Well, it turns out the applications are, wow, they're incredibly broad. We're talking everything from theoretical physics all the way to understanding how social networks change and evolve over time. This framework is being used to model self-regulating systems in biology and even to build totally new kinds of computer models. But one of its most powerful uses is modeling what are called cascading effects. Think about a massive power blackout. It starts with one little domino, a single transformer fails. Because the system has to obey that speed limit of information, we can now model exactly how that one failure overloads the next station, which then overloads two more, triggering this massive chain reaction that darkens a whole city. This framework is perfect for understanding those kinds of domino effects.
All right, so let's bring it all home. Let's think about what this new perspective really means for the future. What's the next scene in this play?
What causal graph dynamics does, ultimately, is it stops trying to write a perfect, predetermined script for reality. Instead, it gives us the rule book for the improv show. It just accepts that the world is flexible, it's always changing, and it shows us the fundamental, non-negotiable rules that govern all that change.
And that leaves us with a really fascinating final thought. For so long, we've been trying to predict the exact lines in the play. But now that we're starting to understand the deeper rules of the performance itself, what new, bigger patterns are we going to see? What secrets will the improv show of reality finally reveal to us?